So if you can recall, we had started, uh, I mean, with some discussion about arrays. And in the last class, I had started with some illustrative example how arrays could be used to solve many popular problems. And we are taking up simpler problems, and we are illustrating that how the program should be written. Okay. And we had ended up with this exercise for which the solution I have not given yet. Hope all of you have tried, and because the solution I had illustrated here was using some few constant number like 5, but the program can easily be extended for large number of inputs with a fixed limit. Okay, so hope all of you have tried your hand, and today in the lab assignment you will get similar type of uh, problems which will be taken care of. Next, let us try to discuss another problem, that write a C program that checks whether a given number is present in the array of n numbers. Like in earlier, what we were doing, we were trying to find out the best, I mean largest or smallest. Now see here, instead of largest or smallest, user will give one number as input. Let's say try to find out whether the list of numbers which I have inputted earlier is having this particular number present in the list anywhere or not. So see, the same mechanism can be used, because while finding the largest or smallest, what we have done, we had actually scanned, this was our array, this was our array, and we have actually, starting from the second element, we have actually inspected each and every location of the array to find out whether we are getting a number larger than the current largest I am having. So basically, you can say without loss of generality, you are inspecting each and every location of the array sequentially, one by one. Now look at this problem. Although you are not asked to find out largest or smallest, here also you need to start from this very first location of the array to check whether the number present in this location is equal to 100.05 or not. If it is not, you go to the next location and again do the same operation. In this way you will go. As long as somewhere, if that is present 100.05, you will get a match and you will return the index, maybe index of that particular array, that okay, I have found this number to be searched at this location, at this index. Now, in the worst case, what may happen, that it may not be present anywhere in the list. But how can you be sure? You have to search each and every location, and when you reach at the end, last element, and still you don't find any match, then you declare that okay, this 100.05 is not present in the list. So strategically, you see, the main or core of the problem or core of the solution will remain almost same. There we had used one relational expression, whether we are getting something current element under inspection is greater than or less than my largest or smallest. Here, what I will do, I will take this given value inside an one variable, and I will do the same thing. Now, instead of finding greater than or less than, I will just check for exact match. But thing is that what I am doing in general, I am searching, be it a number, given number, or be it a largest or smallest or any kind of element having some property, I am searching the array linearly. Linearly means starting from the very first location, one by one sequential. And that's why this technique is often called linear search. Okay, this is a very popular technique. We will be using this linear search in solving many types of problems involving list of numbers, whether we need to find out largest or smallest or some other number in the list. So this linear search is generalized mechanism which will be very key in solving many problems. Okay, so it is not only that you are asked to find a given number. Whenever you are asked to find a maximum or minimum in a set of numbers, then also you employ this linear search. Understood? So this searching and sorting, probably you have heard. This is a very popular sorts of problem we encounter in computing. Okay, this searching. Is it clear, students?
Yes,
Hello?
sir.
Okay. Okay. Now, there is another search mechanism which many of you may have heard, that is called binary search. Okay. The binary search. Binary search is often very helpful and means it's much efficient than the linear search, because in linear search we have to search each and every location of the array. So basically in the worst case, when the element to be searched is not present in the array, or when my largest element or smallest element can be found at the end, at the last element, then I had to inspect all the n entries. So it will take at least n comparison. The for loop should run n number of times. But binary search can help us in reducing the number of operations, but its application is restricted. See, linear search can be applied if we don't know the relation between the numbers we are inspecting. Now, in some cases, what happened? We are given a list of numbers which are sorted already, like 3, 9, 11, 13, 17, like in ascending order or in descending order, 23, 21, 19, 17, in this way. If they are sorted, then we can employ this binary search technique instead of linear search. Linear search will also give the correct result. Linear search is more general, but binary search can be applied when we know that the array we have already constructed or the list of items we are given into which we have to search or into which we have to find some element. Then we can, instead of applying linear search, we can apply binary search. Okay, so this thing is very important to note, that binary search cannot be applied on an arbitrary list unless it is not mentioned that it is sorted by some means, either in ascending order or in descending order. You cannot employ binary search. But if it is given that you are given a sorted list, sometimes in some problem you may find this, it is given, or you know that you have already sorted for some other part of your solution, you have already sorted the array. Although initially it was given unsorted, but you need something to do it. For that, you have already sorted the list. Now there you can apply this binary search. The binary search, what is the technique? Suppose this is the array given. Now element to be searched is given like this. I am illustrating. So it will just find first the middle element. Middle element here, 1, 2, 3, 4, 5, 6, 7, 8, 9 element is given. So the middle element will be this element. When there are odd number of elements in an array, then middle element is unique. But when there are even, if there were 10 elements, then there could be 2 middle elements. You can choose any one, either left one or the right one. Okay. But you have to be consistent. Each time you choose it, the left one you will choose. Understood? But without any complication, let us assume for this particular illustration, the number of elements are odd. So this is the middle element. Now what I'll do, I will just compare with this. Instead of sequentially starting from the left, I am first checking the middle element and I am comparing whether it is matching or not. Okay. If it is matched, if it was 35, I will get, by one comparison, I will get that. Otherwise, what may happen? It may either be less than that or greater than that. Okay. Now see, if since this is found to be less than the element to be searched, I am now sure, since the array is already sorted in ascending order, the element, if it is present, it can only be present on this side. It can never be present on this side. Understood my finding? Whenever I am comparing the element to be searched with the middle element, I will not just compare it for equality. If equality fails, then I will check whether it is greater than or less. If I find that current element is less than the element to be searched, then I will now confine my search on the left half of the array. If it was say 37, then 37, since it was greater than 35, that time I would have restricted my search on this right hand side, not on the left hand side. Okay, and I will repeat this step with now this half. This half again I will try to find out the middle element and again compare, and in that way it will. Okay, since 23 is less than 35, actually I have to search on the right hand side. Okay, so actually in this particular example I will concentrate my search on this side. Fine. And then on the next step again with the smaller array, this part, I will look into this middle element again and again compare. Since this is found to be less than this, then I will again divide this array into two halves. Now I will concentrate on this half and this will be my half, and then finally I will manage. So at each step, my area of inspection is becoming half. It starts with n. I will never compare all the n elements. I will start by comparing middle element, then n by 2. Then again with that n by 2, I will compare with the middle element. Now my area of inspection becomes n by 4. In this way, it will be reduced. So I don't need to inspect each and every element. And that's why at the end, the number of comparisons or number of basic operations I will be doing will be much less than that n, which is actually, it turns out to be log n base 2, which is much less than n for large value of n. Okay, so this is why binary search is often employed when we know the array under inspection is sorted. Is it clear?
স্যার
Yes, sir.
হুম
স্যার একটু
হুম
বুঝতে সমস্যাই হচ্ছে।
হুম বলো।
স্যার বলছি আরেকবার রিপিট করবেন, শর্টের ব্যাপারটা বুঝলাম না।
হ্যাঁ হ্যাঁ,
স্যার শর্ট, স্যার হোয়াট ইজ দ্য শর্ট? স্যার
sort
এখানে
means arrange in sorting. Oh, sorting you don't know. Sort means arranged in such a way that either their values gets increased in a order. You see 3, then 7, then 11, 18, 23, 27, 21, 35, 34. So this is arranged in ascending order. That means the elements values are in increasing mode.
ওকে
It
স্যার।
is not, I mean, when I place 27 and then 23, this is unsorted because 27 is greater than 23. Understood?
ওকে স্যার।
Sorted means usual meaning of sort. Sorting with respect to some order. order of their values, either in increasing order or decreasing order. Understood?
Yes, sir.
And when that is guaranteed, that is given, then only this binary search technique can be applied. Because what I am doing, I am, instead of inspecting each and every element one by one, I am directly coming to the middle element. And by checking whether my element to be searched is greater than that middle element or less than. Now what I am doing, when I am finding that this element to be searched is greater than middle element, then I am sure, since it is sorted, this element, if it is present, it can only be present on this right hand side. I don't need to search here. All the elements on the left hand side are less than 23. So they can never be equal to 35. So why
Yes,
do
sir.
I search here? I'll leave them. So that's why in this way I'm actually reducing the number of unnecessary searching,
Yes,
and
sir.
which is making my number of operations less. Hmm,
Yes,
understood?
yes,
Okay.
sir. And
So that's why linear search is most general. When you don't know whether they are arranged in sorted manner or not, you can employ linear search. But when you know explicitly that it is sorted by some order, then instead of using linear search, binary search will make your algorithm run faster and make your solution more efficient. Understood?
yes, sir.
So this illustration I am skipping, it is given. When you will get this slide, you can check that. Okay. So here, one more thing I need to, I mean, there are two types of implementation, recursive and iterative implementation of binary search. Okay. How did you will go for step by step. As if first you will look into middle element of the entire array, then the next, the middle element of the right half or left half, and then again iteratively doing that thing. So recursive implementation will be discussed by Joydeep sir when he will discuss user-defined function and recursion in more detail. Okay. Iterative, you can easily look for that. I'll upload this particular example also. Not today. I'll ask you, all of you, to try your hand. After knowing the strategy, the algorithm I have described, try to, from that, try to write your own program. Then I will give the solution. Okay. Now these are two more examples. I mean, some examples which you can try of your own. That write a C program that counts the frequency of occurrence of a particular digit in array, any given number. Okay. Now suppose this is different digits are there in this number. There are two ones, four two, and 1 3. Okay, so this is whose frequency is to be counted, say 2. I have asked you to count how many times 2 appears in this number. Output should be 4. Now, how can you do that using array? You think it is a whole number. Okay. Now you have to actually be able to extract each and every number separately. So there are techniques through which you can do that. Hmm. So this may be an exercise you can do. You try your hand. This type of exercise. Okay. Now I am going to discuss another problem. Just like when the array is sorted, you can find a given number, whether that is present or not, using binary search. Now I am changing this problem a little bit. That I am given a sorted array already, and I want to insert a new element. Okay. Now I will be, after insertion, I will arrange in some manner that the modified list remains sorted also. Like initially, suppose I had, okay, let me give an example first. Say I have 2, 4, 6, 8, 10. This was my initial list. Okay. And there were some garbage values. Let's say the size of the array is a little bit. Now I ask you to enter 5, insert 5, such that the updated array also remains sorted. That means if I just add 5 here, 2, 4, 6, 8, 10, and then 5 with 2, this output is not desired output. What is the desired output? 2, 4, then 5, then 6, then 8, then 10. This is desirable. This is not. Understood?
Yes, sir.
So after insertion of the new element, the list will be a different list. Obviously, earlier the list length was 5. Now the length of the list will become 6. Now if I place that 5 at the end, it may not, now this modified list may not be sorted because 5, the value of 5 is not greater than 10. So it has to be placed in its proper position such that we get a list which is again sorted. So how to write that program? Let me illustrate the algorithm along with
सर
site. Hello.
सर 10 के बाद 3 डिजिट है इनपुट में और आउटपुट में 10 के बाद 2 डिजिट है सर
मतलब 10 के बाद
सर 3 डिजिट है ना और
गार्बेज
वाला?
वैल्यू बोल रहे हैं
ये वाला?
हाँ सर
ये? हाँ
हाँ
नहीं, ये डिजिट नहीं, ये गार्बेज वैल्यूज है.
अच्छा
मतलब
अच्छा
मेरा एरे साइज, what was my array size? This was 0, 1, 2, 3, 4, 5, 6, 7. Unless I have enough size, if I take only 5 size array, then I won't be able to insert anything there. So what I am taking, I have started with a little bit larger array so that I can allow some new elements to be entered, because my list length will increase after insertion. Where do I put? These are garbage values. Garbage means unknown values. I don't know. I am interested up to this. And now when I am inserting new element, I initially insert by overwriting this garbage value at the index 5. And then I am rearranging these elements within this up to this 5. This portion is not my headache. Understand? Are you getting my point?
यस सर
See, if I started with only 5 size array, then how can I enter any element, insert any element? That's why I have to, at least if I allow only one element to be inserted, I should start with 6, one garbage element. But I have assumed that I will be able to insert more elements. At least 3 elements I can insert. After that, again, I may allow one more element to be entered. Okay. This is the physical restriction of the array. That's why I have to take that. And I cannot dynamically change the size of the array. That's why. Okay. So what I am doing here I have taken, for simplicity, I have declared a size 5 array initially, and I am hard coding that. I am making this array sorted. I am taking the array input sorted for easy illustration. But sometimes you may so happen that you have to collect the input from the user and then you have to sort. But we still don't know how to sort, how to write a program to sort an array, which we'll learn later. Okay. But for the time being, you see that you assume that user is giving the elements in proper order so that they remain sorted. And here, for saving the space, I am hard coding that the initial content of the array I am hard coding. Understood? So obviously, when I initialize with this first 4 element, the first 4 elements of the array will be initialized like this, and the fifth element or element at index 4 will remain as garbage, unknown value. And I am assuming it is already given in sorted matter. I don't need to bother, it is sorted. Now I am declaring this num variable to accept one new value which I need to be inserted in this array, and I have to make some arrangement such that after insertion of that array, the list of 5 elements there. So far it is list of 4 elements. That time it will become list of 5 elements. That will also remain sorted. And this I am using as an index variable, which I will be using for doing some iteration. And why I am initializing it is 3. I am coming to that. 3 is basically the index of the last element, up to which I have valid element in the array. Understood? This is 0, 1, 2, 3. 3, I am initializing I with 3 because I know physically I have to insert the new element after 3. Understood? Otherwise, if I say the new element, if I insert anywhere in this index, then some original value will be overridden, which I don't want. I initially obviously accept that input and put it in the next available space. And for that, I am assigning with this. I must know the end of my list. Index, actual end of my list, not the actual end of the array. Array may be larger than this also. Fine. Now what next step I am doing? I am asking for the input, this. So num will get some value, let's say 3. User has input 3. So what I am doing, I will, without anything, what I will do, I will check. I will start checking from this side because I know this is sorted in ascending order. That means increasing value. So I will not start comparing with the last element. If it is found greater than this, that means I know that the position of this new element will be on the left. Had that been 13, then what happened? 8 become less than 30. Then I knew that the position of this new element will be on the right of 8. So I can safely override this position with 30. But what I have found? I have found 3, which is less than 8. So I obviously know that its position will be somewhere on the left side. Now where, I don't know yet. So next what I'll do? I'll come here again. Then I will again compare with this and this. And since 6 becomes larger than 3, then I know that its position will be again on the left side. Now I'll inspect with 4. Okay. And again I find that 4 is larger than the given element. So I know this is on the left side I have to go. Now finally I inspect with this 2 and find that 2 becomes lesser than 3. That means 2 should be on the right side of 4. So just before that I have come to know that it should be placed on left of 4, and now I have come to know that it should be placed on right of 2. So it should be inserted between 2 and 4, somewhere here. But see what is happening. I know this position, but how do I insert? There is no vacant space between 2 and 4. Understood my catch? I mean, I have identified the position, but I cannot insert because insertion will actually is not possible because there is no space between 2 and 4, and I cannot overwrite any one of 2 or 4. I have to keep both of them and insert 3 between 2 and 4. So for that, what I am doing, let's see this iteration of this thing. What I will be doing, each time I am getting to note that I have to go for left, I will actually shift this element one by one. That means whenever for the first time I have found that 8 is larger than 3 and I have to go left further. So what I will do, I will overwrite, I will shift 8 here. That means I will move 8 here first by overwriting this unknown value. Now I have 2 8. Now safely I can say that between 6 and 8 there is a space. I can use this space. If I overwrite this space, there will be no problem because I have already shifted 8. Okay. Now when I find that no, this is not the correct position, I have to go left further. So I have to keep a space between 4 and 6. So what I will do, I can safely now shift 6 here, overwriting 8, because 8 was already shifted towards right. So overwriting this 8 will not create any problem. Now we have 2 6. So when I come to 4, this comparison, and again I find that I have to go left further, I can safely overwrite this 6 with 4 because the original 6 is already available here. So in this way I will go. I will not just left check that whether I have to go left or right. Whenever I find that I have to go left for searching the actual space, I will be also keeping the arrangement of the space so that at the end I can just overwrite it safely. Let me illustrate. I have the illustration in this slide. Look at this illustration. I am going one by one. Okay, how this particular body of the loop works. Iteration 1. I greater than equal to 0. I was initialized with the last value. And I know that element, whatever element I give, it will be, in the worst case, it should be inserted before the first element. So it can never go beyond 0. I cannot have a -1 index. So this is one condition, and this is a composite condition. As long as the current element is found to be greater than the input element, I have to do these two operations. I'll just arrange space. While the shifting can be done xi plus 1 equal to xi. That means xi initial value is 3. So what is the value of xi plus 1? x4. So this, for the first iteration, this particular statement boils down to x4 equal to x3. And what does that mean? x4 is this one, should get this value 8, overwriting this value like this. Understood? And value of I gets decremented by 1. In this way, iteration number 1 gets completed. Okay. Now iteration 2, value of I has become now 2 because it was 3 and now decremented by 1 from the first iteration. Now again 6 is found to be greater than 3. Okay, so these both the condition becomes true. So now this particular statement boils down to x3 equal to x2. That means now safely 6 will be overwritten here and I will be decremented by 1. So current value of I is 2. I will become 1 and it will go for the next iteration. So this is the end of iteration 2. After end of iteration 2, this is the status of all the component. See, there is 2 6 now. So that means I can assume this as a vacant space logically. Although physically it is not vacant, but logically I can say that it is a vacant space. Understood? Next step, since value of I is 1, which is greater than equal to 0, and again xi means x1 is greater than num because x1 is 4 and num is 3. So I will do the same thing. This 4 will be overwritten here and value of I will be decremented to 0. Okay, so this is the end of iteration 3. Now after end of iteration 3, this is the status. There is 2, 4 here. Value of I is 0. Now, so this condition is in iteration number 4. This condition gets satisfied. But see, this becomes invalid. Now x1, x0 is not greater than num. So together, since it is compounded by a logical AND, this will be treated as false. So the while loop gets terminated. Understood? So iteration 4
Yes, sir.
will terminate. And at the end of iteration 4, status of this value is like this. There is 2, 2, 4, then 6, 8, and value of I remains 0 because this statement has not been executed, and num remains 3. Now what I have to do? After this while loop gets terminated, I know that this is the correct position of the newly given element, because in the last iteration I came to know that it should be on the right side of 2, and in the previous iteration of the last iteration, that means second last iteration, I had came to know that it should be on the left of 4. And logically I know, although there is a 4 present, this is logically acting as a vacant space. So I have to override this now, not with 2, but with 3 or num. So I will add this statement there. xi plus 1 equal to num. Remember, this has to be I plus 1 because i's value was set to this value. If I had written xi equal to num, then it would have been an erroneous case, because then these two would have been overwritten, which is not desirable. So before inserting the final element, you have to keep in mind that it should be incremented. I should be incremented by 1 so that you can in its proper place. Got the entire procedure? How you can insert in a sorted list? What is the mechanism and how this program segment can implement that mechanism?
Yes, sir, got it.
Okay, very good. See, this is very important because although we have, implemented this insertion operation in already sorted array, but this technique can be easily extended to sort any arbitrary array. This is very, very beautiful thing. That's why I have what is this technique I have used? I think all of you, those who have played cards physically, not with computer, they have experienced this solution strategy. Can you tell me anybody have played cards, I mean physical cards, taking them in hand?
Yes, sir.
Arranging them in KQJ 10, 9, 8, 7.
So when
Yes, sir.
cards
Yes.
were distributed, now you used to keep cards in some arrangement, some sort, I mean maybe in ascending order of their points.
Yes, sir.
Now you used to pick up card one by one. Nah? And it is a usual practice. When you get the first card, you put it on your left palm. Then when you get the second card, you actually check whether the new card, based on the new card's value, whether you have to place it on the left side of the first card or the right side of the first card, isn't it?
Yes, sir. Yes, sir. Yes, sir.
So after you have got two cards on your left palm, you keep two cards arranged in proper order, either ascending or descending, whatever you want, based on their value. Then when you get the card number 3, you do the same thing. You now insert the third card inside this already two cards in its proper position, so that at the end the 3 cards remain sorted in their proper order in your left palm. Then again, using your right hand, you pick up the 4th card and do the same thing. So this algorithm, which I am describing here and which can be implemented using this program, is basically mimicking that strategy, isn't it? Isn't it analogically similar to that strategy? When you pick up cards
Yes,
one
sir.
by
Yes,
one
sir.
and keep them arranged in your left palm.
Yes, sir.
Yes, sir.
Okay. So this is very common. I mean, there are several ways of sorting, but we'll see this is the most uh, intuitive way of sorting. That is called insertion sort. I will discuss that thing in next class. And the whole philosophy of insertion sort has been borrowed from this our normal practice. Right. It is not, we are not sorting it. I mean, the problem of sorting is a little bit different. Here, this problem is I am already given a sorted array and I am inserting one new element and I am maintaining that sorted order in the updated array. But if I know that how to do this, I can use this repeatedly to sort and give an arbitrary array. And that is called insertion, which I will discuss next class. Okay. So this is for today. If you have any more question, you can ask, and we'll take up some exercise today in the lab session, which will actually involve this type of applications. I mean, applications of iterations along with arrays. Okay, some problems
Okay,
will take
sir.
up, and
Okay.
as I have told you, you can also take up these problems which I have already pointed out. Although they are not given explicitly as assignments, you can, for example, this type of problem. This type of problem you can take up of your own and try to solve them. Okay.
Okay, sir.
So any more question?
No, sir. Sir, the
Okay.
bubble sort, sir, the bubble sort method can be. Will you taught it? The bubble sort method.
Bubble sort, if time permits. I don't know, but insertion sort definitely we'll discuss in detail. Bubble sort,
Okay, sir.
I think after knowing one sorting technique, it will be easier for you. But anyway, we can discuss. If time permits, we'll obviously discuss that.
Okay, sir. Thank you, sir.
Okay. Okay then.